So Brett, it's your show now.
Okay. So I want, if one of you guys maybe could take a look at the chat there for me. I was going to share my screen just a second here. I won't be able to see the chat, but I put a couple of links up that will get you guys started on your chat. So hopefully everybody knows how to use your chat. And there's a little thing where you can raise your hand under reactions if you. But what I'd like to do is have somebody else watch the chat for me while I'm demonstrating, because what I'm going to do, I'm going to demonstrate our mesh network. Okay. Now, we have me and we have Frank. Let me introduce myself again. I'm Brett Popovich, Kilo Golf 7 Golf Delta Bravo. I'm an extra. I've been doing ham radio since 2013. My colleagues here, Frank, Kilo Juliet 7 Delta Zulu, Declan Kilo Golf 7 Hotel Tango Echo, and Dan Whiskey Alpha 7 Alpha Bravo uniform are members of people who I've worked with to get this network going, and they're sort of flies on the wall, but they can answer questions. We started doing this stuff because everybody sort of has this bent of, well, we want to help out in an emergency, we want to have an emergency, communication system. And let's see, how many of you, just before I start, have done any work with ARES or any of the emergency comm people? Okay, how many people? Sub 3, 4? Okay, how many people have used WinLink? WinLink, okay, WinLink over HF. All right, so good. All right, have you noticed something about WinLink over HF? It used to work really good. We do these statewide sets. And lately, WinLink, last couple of times, even pre-COVID, they tend to try to make it hard on us. They go, oh well, here, go deploy over next to the waste burner on that generates electricity over in Brooks, and see if you can do these contacts. Okay. Well, anyway, what we found out is that there is so much traffic regionally when people are trying to do conventional HF. And then we're all using NVIS type antennas, and pretty much during the daytime. And so pretty much we have a choice of 40 meters or maybe 30 meters. And if you've ever done any of this stuff, it's kind of frustrating to get out there and try to make a contact. It goes very, really slowly. You either get even if you use a Pactor modem, you might get a busy signal. And the way packet works is it sort of sends this information out, and then it kind of wants an acknowledgement and keeps sending your message. And sometimes it gets almost all the way through the message, and then it just stops because the band conditions have changed and it's really noisy. And so it oftentimes takes us hours to get the basic information out, just activating our unit and sending a status report. Couple of little things, not like we're sending a lot of traffic. We're just sending some status reports, and HF is just terrible. Okay, and too many people using it, what have you. Now, we are using portable stations. We don't have big contesting stations. We don't have a lot of power, and oftentimes we're not where we want to operate. Well, that's the way it works in an emergency too. Okay, so I think Dan and I were kind of saying, and the problem is we go and try to help out, and they never let us use their computers. They always hand us a piece of paper, or they hand us they might generate some messages for you on a thumb drive to send. But you're supposed to send traffic, right? Written traffic. And that's the issue, is that we practice giving oral traffic, and it takes about 10 minutes to do the ICS 213 form with even a small amount of information. It wasn't really designed to be delivered by voice, okay? So coming from this is that there gotta be a better way to do this. And so we did hear about the AREDN network, and AREDN stands for Amateur Radio Emergency Digital Network. And we found out that people were leveraging the power of long-range Wi-Fi routers that were used for commercial internet providers that we call WISPs, wireless internet service providers, or fixed wireless providers. Found out that there's a group of people starting with these little old, blue Linksys routers. They started out with some little routers for indoor use, and then they expanded to these bigger devices. They were just changing the firmware to allow them to transmit on ham frequencies and to give us a little more flexibility in what they could do. Okay, so as a ham, it doesn't matter what license class you are, we have the right to modify and test equipment and make it for our uses. So with that in mind, we learned about the AREDN group. I'm gonna, let's see, I'm gonna go to my share screen here and I'll just, there's 3 links there. AREDNmesh.org is the group that we use the firmware from. They make it, it's free, and we put it onto radios and then we deploy them, all right? Now, let's see, last other thing I want to tell. And again, if you guys have a question, type it, and then I guess Anthony or somebody will let me know if you have a question that I can, and I'll pause and if you think it's appropriate. Okay, so MESH is not an acronym. AREDN is an acronym. MESH it comes from, it's a form of ad hoc networking. Okay, so I don't know if people have done much networking, but you know, probably you're used to having a Wi-Fi router and walking in with your phone and having it connect, you know, but you notice that pretty much you can connect to the internet, but you're not really connecting to your other, you know, devices in your house. They're just on there, right? You're not talking to your TV set or whatever, but you can do it if you set it up, right? So doing more elaborate networking in sort of a LAN setting, a local area network, usually requires a lot of you know, technical setup. You have to sort of figure out, oh, what are the addresses of my device and how can they connect together and make sure everybody has the correct address and we know what they are. And we have all these firewalls and privileges and things like that so that they can talk to each other, okay? Well, it turns out if you can take a commercial router and you change it to this OpenWRT firmware, it allows us to add on some additional packages. The package we use is called OLSR, which is basically a mesh networking package. What it does.
Are you trying to share something?
No, not yet. I'm just going to talk. I'm just talking right now to get your attention, so we don't. And then I'll do the share. Hold on. Okay. So what I was going to say is that just the idea is that when you bring 2 radios together that are on a mesh network, they find each other and they talk to each other. Okay. If you bring another radio in, it finds that's called auto joining. And somebody leaves, and auto healing. If they leave, it doesn't break the network. Okay, so those are some basic mesh things. Okay, now I'm going to take you to the website so we can see what we're talking, where you can get some information. So I'm going to share. Let's see where I put my screen. All right, so let's see. So this is AREDN. Can you see the AREDN website here? Are we sharing?
Yes.
Yep, we're good.
Okay, good. So that's AREDN, Amateur Radio Emergency Data Network. Okay, and this is the place that gives us our firmware. And they have a lot of stuff on this. I'm not going to go through, you know, what is AREDN, all advantages. It's very, very well documented. It works. It has all the information. They give us all the firmware. And the other thing that is very nice about it is they constantly are updating our firmware and adding new devices. But for the most part, we're actually using sort of a little older generation of radio, and it allows us to get some good deals from some of the providers who are updating their equipment, so we can get some used equipment. Okay, those are pictures of some AREDN devices. That's a nano station there. There's a little slideshow here. We have amateur radio bands, 2.4, 5. We have 14 unshared channels on 5.8, and they're sort of after those right now. These are pictures from LA. Those are rocket devices. They're a type of a radio that goes on to bigger dishes or sector antennas. That's a small nano station for home use. That's a big 900 antenna. We have 2 of those. They're AREDN dish that's bolted onto a thing. We even have little tiny AREDN devices that can plug into a USB port. Typical kind of setups are dishes on poles hanging on top of buildings. Southern California doesn't have any trees. You're gonna have a different perspective on trees when you start this, guys. let's see, okay, so let me go back. So anyway, this is AREDN, and from AREDN you will find the under software, you'll see a bunch of different things. The radios that they use are in a table form so that you can just go down and pick some of these radios. Move my chat. Otherwise I can scroll. Okay, and you just pick one of these links, and it actually takes you to Amazon. I guess those guys make a little bit of money when that happens. But then it will. You can't really go wrong buying the wrong device, because they've already chosen devices in green here that are supported by their firmware. And for the most part, after a while now, I think they have about 70 different devices that they can offer. Okay, let me go to my screen. Okay, so here we have a little web page called the Willamette Valley Mesh Network page, or WillametteValleyMesh.net, and I put that link on your chat program. All right. This has just an overview of kind of a philosophy that we come up with, that this is a Part 97 wireless local network that runs 24 hours a day, all the time, so that it's ready for use and we can train on it. Unlike any of the other kind of emergency stuff where you kind of pull it out of the box and sort of set it up and hope that it's going to work on the day of the exercise, we have it running all the time, okay? We have, this has links to our, basically to the AREDN, and describes a lot of things. You can read through this. I'm not going to read through it now. Obviously, we use repeater towers if we can put things up, but for the most part, we are not, I'll just mention, we are not sponsored by or owned by or pay any fees to do this. This is a grassroots ham network. You buy your own stuff, you get on the network, okay? I'm not gonna stop you. If you wanna have you're a nonprofit, you get somebody to donate to you, that's great, okay? Because that means you don't have the expense. But what we decided is that for what the bang for the buck, it's worth it to buy a system to get on this network, because it is extremely useful, okay? Now on this thing, I wanna point out that you can look at our, let's see, one more thing here. You can look at, we have a mesh map, which you can look at here. One of the things that we do is we have a map of Oregon with all of our links on it. And this is generated by software. I'm going to show you the live one that comes off of our network. Right now, it's showing 124 devices that are on the mesh network in Oregon. Okay, just added one over here in Eastern Oregon by tunnel. We have some areas that are separated geographically, but we are growing. I think the first demonstration we did this in the last Rick Rial site for the Oktoberfest, Swaptoberfest is. We didn't have one last year, but we had one the year before. And at that time we had 40 nodes, okay? And we brought that mesh network out portably, put it up in the parking lot at the Polk County Fairgrounds, connected to a repeater at 28 miles away, and demonstrated the mesh network within, and joined the two buildings together with telephones and devices, all portable, all operating off the power that was available there. So this is something that can be brought out and set up in a site where you need to do some high-speed networking, okay? Now, so as we're growing more services, and we have a listing of services that we offer that most people are, we distribute the services using things like Raspberry Pis, okay? So this mesh map that we have is a service, okay? It's somebody else figured it out for us, actually, down in Southern California, and put the information out. We programmed it and put it on a Raspberry Pi, so that those are the kind of things that run our services. We can run other file servers, cameras, weather stations, chat programs, mesh chat. We have the entire Wikipedia on the mesh, okay? The idea being that this network, it's designed to run really, if the network goes down, if the internet goes down, our network is running independently. It's a local area network with a lot of connections. And what we found already is, you know, with our fires and our ice storms and things like that, it has not gone down in the, you know, the couple of years that we've had it going here. Now, I think Lynn County was the first in the area. I think they've had their stuff up for about 5 years. Then Florence came online. They were doing their thing. And what we did was when we started out, we said, well, we want to have a mesh network. We didn't really know what to do, but we noticed that, hey, look at that. When we looked at the AREDN stuff, that there was this other 2 networks, and we contacted them and we said, we want to join to you. And so we did. And so by using tunnels, which are a way of firmware that's built into the thing, we were able to connect our meshes together. And we build from there. And we're trying to add county to county. So if you ever do emergency stuff, they always ask you, can you pass information from all your neighboring counties? That's a goal. Yes, we can. Okay. Any questions?
Real quick, Brett.
Yeah.
The tunnels, you keep mentioning tunnels. To clarify that for those that don't know, the tunnels are connecting the nodes over the internet. So while we may not have geographical line of sight or RF connection, the tunnel goes to the internet to connect the node to the rest of the mesh map.
Yeah, so I'll show you that on the mesh map, that there are some. All right, this is our live mesh map. Okay, and we have, you can tell the color scheme here. The green lines are RF links here, and the gray lines are tunnel links. Okay, so I'm going to zoom in. You can see we have a lot of tunnels, and a lot of people can't get out, and we start out with tunnels. The tunnels are built in. In fact, I am tunneled right now to the network. Okay, but what's cool about this is most of the purple dots are tunnel sites. Okay, but I can go to any radio on this network by clicking the map and find out what it's running and arrive at their location. Okay, so it's a way of telling that whether the system is up, what radio they're using, what frequency they're on, whether an RF link or a tunnel link. I can pull up a list view of all the users. I can do a search. And everybody's got latitude, longitude, and tell what kind of firmware they're used. This is all management stuff. But if I want to, you know, go to a particular node, I just click on these links and I'm there. Okay, so if I go to, bang, this is a node that was put in just last month on Chehalem Mountain. This is a repeater node, and it has so comes up like this with common web page. The way you operate the mesh is using a web browser. You can use any web browser on any device. You just have to get onto the mesh. It's very cleverly done. It figured every device is a router. What that means is it gives you your address, and it keeps track of you, and sends that information to the rest of the mesh network. And so we can go mesh status, and we can see, oh, what's happening with the mesh network? Well, you know, this particular one, it has a current neighbor, which is that's telling me that it's putting out 14.4 megabits of signal, and it's connected to this other station over here, N7 TV. And then it has a whole bunch of other nodes that it's connected to, and it goes down the list, not alphabetically, but by the link quality, basically, the link distance, okay? Goes down there, and then we have services down here so that we can just click on them like this mesh map and comes up with a service. Okay, so if we want to go to a file server or to a, for example, here's a something called Citadel. Let's see if that works for us here today. This is Citadel. This is a server that I put on a computer, and it is, one of the nice things about this is a self-registration email system, and it has a calendar, it has you know, notes, it has contacts. You don't need an administrator to make an account for you. So in an emergency, you can just establish your account right there and start using it, okay? So that's a service as an example of a service on the mesh network, okay? And you can chat with people and you can do files and you just have to, the stuff is on there so you can learn how to use it. All right, so that one's called Citadel. All right, we have other, besides the mesh map and Citadel, we have lots of other services on the network, file servers. It works with really anything that is, you can kind of think of it works on the network. So we have a telephone system. We have that uses what's called Voip phones or PBXs phones, okay? So you can make a phone call. So if you can imagine, helping out in an emergency, yes, you're a ham radio operator. You have your call sign. This is, again, it's run by hams, okay? Every device, this is one of my devices here, has a call sign, all right? And I'm the control operator, but I can say, you can use my phone. I can establish a phone and anyone can use that, providing they're not doing commercial ordering pizzas, what have you, okay? But that's one of the main services that we have. We want to be able to actually just have someone talk on the phone. And the remarkable thing is that we're doing full duplex over ham radio. It's just amazing. You're both talking at the same time, and we're using ham frequencies, which I think is a neat thing. So anyway, so you have a mesh. We have 124 nodes right now. Goes up and down, goes, as we add and subtract things. We have a lot more equipment out there. So that's it for what sort of the overview of what the mesh is. I'll talk more specifically about what the equipment does. And let me see if there's anybody has any questions at this time. A lot to absorb there. I'll talk about what these things look like, how much it costs, that kind of thing. Anybody have any questions here? So, okay, good. Well, I guess I'm not boring you yet. All right, so recently we've added Eugene to our operations, okay? So you guys might know some of the packet hackers on the Valley Radio Club here. I don't know, you guys compete with them in contests, but they're actually good people to probably get to know, okay? And I helped them out. We started out with again, using a tunnel device, which is just a small home router you buy for 49 bucks. Called a HAPAC light. It's from our AREDN stuff there. I can show you that again. But anyway, they started out with a tunnel and they're build up a small network. We call that a mesh island, a bunch of users like you guys that are interested in talking together and using this equipment, learning it. And then they go to try to make RF connections, all right? And they have to experiment with these dishes now. And we suggest you use 5.8 gigahertz for your connections. The reason being that the equipment is much smaller and portable and lightweight and unobtrusive, and it has a lot more gain, and we have a lot more bandwidth available to us, all right? Let's see. Why do we need bandwidth? Bandwidth gives you speed, all right? So we're using, can anyone tell me what was your typical packet connection? What is that, what is that we use on the old KPC3s and things? What
it's
sort
like
of
1200 baud, Brett.
How much?
1200 baud.
1200 baud, yeah. And what is it on 8?
Oh, 300.
Yeah, 300, yeah. Okay, all right. So we're megabits. I want to show you something real quick here. You ever use WinLink?
Mm-hmm.
Okay, WinLink has got the ability to do a mesh. Okay, it's already built in, which is really cool. Okay, all I have to do to send WinLink is I need to go to a different setting in WinLink. You can see this here. Are you still seeing my WinLink message? You open the session, instead of saying packet, we open the session called Telnet Post Office. There's all those other things up here, right? You go to. Well, Telnet Post Office, we have WinLink stations on there, and you just open them up. And let's see, I have a little test message, just typical little text message. I'm gonna send this to my friend Frank here. I'm gonna just send a message here. let's see, it's going to connect and nope, I guess it's done. Let's see. 100, okay, and then we're done. All right, I just sent a message over the network, and looks like it did. Let's see, sent the one message, 125,974 bytes per minute. Let's see, usually give it in bytes per minute. I typically, yeah, around 1,200 is what we get on, a really
It's like
good connection.
10x there.
Okay,
Right.
so it's done and it's gone. Now the advantage of this is I can leave this running, and it'll connect every couple of, whatever I want, every minute, every 5 minutes or whatever. But you see, I'm not tying up the network. I'm not tying up the spectrum. Just send this message and get it out there, okay? And then clear off, and the next guy can use it. I also can send a peer-to-peer message within our system. If we're sending, this is going out, actually, we can send it to Florence. Florence has a backdoor station. If their WinLink is down, the tri-mode thing takes care of it. It sends it by backdoor, okay? But within the network, it's Zoom, it's gone. We can also do peer-to-peer, and we can send pictures and anything else. It really not a much limit to what size we can send. I think we can go 5 megabytes on a WinLink message versus 100K. Okay, so it really makes WinLink sing, which is just great. Okay, and if you want to check the mail again, you just start it, and it just checks it. Didn't get anything back. So, but actually, so, yeah. Anyway, but that's all it is to it for WinLink. Much faster, much more efficient. Okay, so that's the kind of thing that drove us to do this stuff. It's up all the time. It's not, I don't need to go get I just need to use my computer, bring it onto the network, any computer, it gets the address right away. If my computer's broken, I can put another computer on there. It gets the address from that radio, gets on right away, and I can continue to operate. So yes, you do need a computer, but you are using, radio wireless links to get long range, okay? Now, how long range do we have? Again, on the mesh map, we are, let's see, I was going to show you these guys. Okay, packet hackers. Okay, they went out and tried to do a connection from your favorite Prairie Creek Mountain. Okay, they'd love to get on Prairie Mountain because they did some amazing testing. This is Matt and Nathan, and this is a Power Beam 400 on a post here, and they were trying to reach Corvallis Hospital. So because Corvallis Hospital has a network. So there's a picture of their position there. Is this getting in the way? There's a picture of them. AI7NC is here. This is on their Packet Hackers group, by the way, if you want to join that. And they have they're showing you this view. You have a great view up there on Prairie. Okay. There's the Corvallis Hospital. You can barely see it, but this kind of line of sight stuff is just awesome for mesh. Okay, zooming in there. Okay, so they connected. They got 17 dB of signal to noise ratio on their signal, and were able to get onto the network, putting out something 19.5 megabits, and they did a bunch of pings, and they're all real short, 62. Let's see. Yeah, these are the pings that they were getting. So they were pulled up the mesh map, saw they were good. And this was showing the connection here. If you can see that, this is AI7. This is the mobile station. This is the Corvallis Hospital, and it says here 27.25 miles. Okay, and all that speed from the back of a car. Okay, they decided to try. They even pulled up a game server as an example. That's I think the ones the kids like, the little Lego block thing. Minecraft. That was a Minecraft thing. They showed that they could get on Minecraft on the mesh. This is a Google. We use Google Earth a lot to figure out whether a connection is going to go. And they determined that they tried another spot and they found out, oh, nope, there's a hill in the way. So they did a profile and said, no, that one's not going to work. And it didn't. That was Washburn Butte. So we spent a lot of the time looking for spots to operate. Okay, everybody wants to operate out of their backyard, and that's great. If you've got something up on a hill, maybe you can, but we have a lot of trees. We do a scan and we try to find stations, you know, and it shows you when you connect. It's got some nice tools to help you find stuff. So they are looking to, and I in Eugene to build up that area to try to get something on Prairie and something on Blanton, and then try to connect to their houses. So it's fun. It's a an activity that people like to do hilltopping stuff too, and we do this looking for signal on a kind of a regular basis to try to find the best spots, and that's what takes the most time. And we'd like to find people who have, like, your house is on a hill and you have a beautiful view of downtown Eugene or something, and you can stick one of these devices on your porch. It doesn't need to be up high, it just needs to be in the clear. So what we say is there's something called a Fresnel Zone. It needs to be 7 feet of clearance around this imaginary sort of torpedo-shaped beam that, or Zeppelin shape, or whatever you want to call it. Sort of a long extended Zeppelin shape that's 7 feet in diameter at 5.8 gigahertz. And as long as it's unobstructed, things work. If it goes through one tree, it loses 10 dB of signal. Okay, so they would lose the ability if it's a, 13 dB is what you get. Well, if you lose 10 by going through the tree, your time is over. Okay, so that's what a field report looks like. And again, this is our live map. I can go to different places, different services. We've got, so let's do that real quick. Our mesh status page, I can just type, oh yeah, there it is. Here's Wikipedia. We put a whole copy of Wikipedia on a thumb drive on a Raspberry Pi. And this is Wikipedia. Now, I think it's pre-election, so we need to get a new version of it, but the stuff is on here. You can search for regular Wikipedia, look up a conductor or something. It's there. And there, circuits are there. The whole bunch of stuff on, you can look up. That's on the computer wiki. Okay. Anyway, it helps us. We'll have some references on here. If the internet goes down, medical encyclopedia. Okay, we've got file servers we can send stuff to. We've got people we can chat live on the chat system, and it's propagated through all of the different chat servers automatically throughout the network. So really pretty remarkable. This fun stuff. I have a web server here that does that scans for radio balloons. Oh, that one's going to come up tonight. It may have just disconnected it. Anyway, lots of things that you can experiment. This is a use for that Raspberry Pi that you didn't know what to do with before. And all these things we test, experiment with, so we're all ready to do this at any point. So, okay, let me pause there, see if there was any questions about the way the network works. It's getting late and people are probably nodding off here, but we're really excited and we want you guys to join individually, or, if you want to make it a club project or whatever. This is the state of the art right now, okay? This is what we, let me stop sharing. I'm going to show you some equipment here. It's extremely helpful. It goes really fast. It's not very hard to do. You don't need to be a computer genius, but you can get help from other people. It's great. You get to meet people from counties like you guys that I haven't got to meet before. I call it, you need to do networking to make the network, right? You got to do a network to have a network. And so, by hams, we have the power to create this thing. Every person that adds their network, their signal to it on RF, adds to the power of the network because it creates another access point. So what's cool is that, yes, it's just not just hilltop to hilltop thing. So we want it to cover the areas where you live. But when you say you get your house and you happen to be fortunate enough to have it on your house, pointing up at the hill, and you're connected to the dish up on the hill, and then all of a sudden all your neighbors, all the hams in your area that close by could actually connect to you too. And when they put their radio on there, that builds the network again. So mesh networks build strength and connectivity. Somebody's waving their hand there. Or maybe Mike's significant is saying, go home, it's too late. All right, here, let me show you something. This is a little bitty 16 dB 5 gigahertz dish. Okay, so it doesn't have to be big or obtrusive. That's called a nano beam M5. Okay, these things run off of Ethernet cables. Coolest thing for you guys that are used to. The radio is in the dish. Okay, that means the power comes from an Ethernet cable, and all the data comes down. There's no losses. No, you don't need waveguide. You don't need high power. It's a 20. This one has a 25 dBm. So about let's see, about 400 milliwatts. There's one. Bill's got one. Well, heck,
I got two.
You've got to put that up. Okay.
Hey, trees.
That's okay. Put it in your car and drive to the nearest parking lot and then get on it.
I actually tested it from Mary's Peak a few days ago, and I caught a side lobe on the Corvallis sector antenna, and it wasn't a very strong signal, but I was communicating.
Yay! Excellent. Well, that's the thing. That's what we want you to do. And if you, all right, let me show you the thing I brought up too. This is a Power Beam 400, which is the same thing that you saw on. It's 16 inches, more gain, heavier metal. It's got a, big bracket on the back for attaching to a pole. You can see that. Okay. Again, the neat thing about this is that up until now, in order to make to work with microwaves, you needed to have some pretty good technical expertise. You needed to get a transverter. You need to get little waveguides, build your own antennas, feed horns, what have you. It's quite the hobby. There's a whole Pacific Northwest microwave division, and they don't even know about this yet because they will.
Brett?
Yeah.
Don and I were the two that installed the 2 nodes on the hospital.
Oh, okay. You're good. You're that Bill. All right. Excellent.
Yeah.
Well, very good. Well, yeah, exactly. So they definitely, you can hit Eugene. They just need to find a place like Prairie in order to hit you, and that would be great. As we build the network, you can have more than one person connect. That's the other thing. It's not single point to point or even point to multi-point. It's a mesh. Okay. So yeah. So ask Bill. He knows how it's working. This can be used for exercises. We need to expand in Corvallis. We need to get more students involved, like Declan and his group. This is exciting for people who are computer nerds that want to do their own stuff, and it's exciting for older guys that just want fast communications and not to have a busy signal when you're using the Pactor or something like that. Let me show you what a sector antenna looks like. They're more imposing. This is a sector antenna, and it looks a little bit like a section of gutter from your house. It's about 2.5 feet long, and it has big brackets on the side. This one came off of Frank's house, 5.8 gigs. This is the thing that's up on the hospital that he just mentioned, Corvallis, something very similar. And it provides 120 degrees of coverage over a very narrow vertical beam width, so that it spreads out over an area and allows different people to get in. Now, the thing is, you can, by working with other people, you get around these obstacles. Okay, if you find one neighbor that's got a good view, you can hit the neighbor, and the neighbor hits the dish, and you're there. So don't give up that you've got a lot of trees around your house. And you need help with that, we do can Google Earth modeling, a lot of things to tell you what will work. But yeah, you can even use your tree. If you have I have an actual WISP provider, the Lyrica guys down there by you in Willamette. They actually, my internet is 80 feet up one of my fir trees. They climbed up and they only charged me $99 to do that. So that's another option for you. Is put your mesh radio in the tree. It works good. All right, so that's the mesh network. It's growing and it's there, and it is a whole aspect of the hobby. It is relatively cheap. The device there to show you the PowerBeam 400 was available used for $65. They're new about 120. The sector antenna is about $200, about 80 for the little radio, and 120 or so for the antenna. They're multi-channel. They have across their what we call MIMO. They have a horizontal and vertical polarization to help deal with reflections and give more throughput. So everything, it's all been figured out for us. The software is free. You just need to cooperate and get it pointed somewhere. And we're excited to have anybody join the network. It might be faster for you guys down in Eugene to, connect to Corvallis and to Lynn County, and then moment you're on, you will be on the entire system. You'll have all of these things available to you. So it will work. You will have a working system pretty quickly. All right, I think I've said enough. It says, why fool around with WinLink when you can use a regular email? Okay. You can email, like I showed you, within the network. Yes. If you need to send the report to somebody outside of our area, say the big one hits, and you want to be able to get in touch with somebody who is operating, I don't know, you want to send a note to the Red Cross or something like that, you could use regular email. That's why people use WinLink, because it goes to anybody can access WinLink from any system, on their phone or their computer or their station or whatever. So it's worldwide, and it has a lot of redundancy in the servers. There's disadvantages. I'll talk sometime about WinLink if you have comments about WinLink. It is one of the ones that is commonly used and it's supported. So that's the main reason.
Yeah, and the other thing is it's a platform that you can use with different backends as conditions change. What happens if your mesh node goes down?
Yep.
Well, you might use HF or you might use packet. It's the same email system.
Yep.
You don't have to transfer stuff back and forth. You don't have to teach people multiple systems.
Yep. Are there any other questions that we have? Again, it would cost you probably less than the cost of a good HT to do this. Okay. So if you get a nano station like Bill has there, pull up the nano station again, Bill. You have your nano station. That's about $80. Okay. You need a piece of cable. It comes with a little power injector like this. You need some jumper cables. This is a power injector, plugs into the wall. Simplest thing comes with it. That's a plug. Hold still. All right. You can plug that into directly. It's 24 volts, or you can plug it into an inverter. The power comes off of this and one LAN cable. You want to get onto the internet for doing a tunnel, you need a little switch like this, as a little Netgear switch. That's about $40 or so. Or you can get one of the little microchip devices, which give you both the switch and we can use different frequencies. Like this device, it's set up to do two different radios, we call them nodes, and two different LAN ports. So each radio gives that addresses. So I could run a camera on here, a Raspberry Pi, two different radios running on different frequencies, different channels. And then I also could plug that into my WAN port at home for downloading firmware and updating the stuff. So, or I can use it in the field, plug a telephone into it, just power it. So it is a network, but it's pretty straightforward, older school network, like plug in the cord kind of stuff. But, pretty reliable.
That's very cool, Brett. Thank you for the in-depth,
Yeah. Anyway, it's a big thing, but I have you can join us. We have a net every Thursday night. We mesh net on 14529 WA7ABU -R repeater on Echolink. I'll put that there. -R.
I have a question, Brad.
Yeah.
Are there any security issues with this kind of mesh?
Surprisingly few. Okay, so it's a Linux system. Each little radio, each thing this is a little bitty Linux computer. Okay, it's a router. All right. So as we know, Linux is less susceptible to problems than it's automatically firewall. We have our own network in terms of it doesn't use the standard subnet. In fact, the subnets can be different. No one has. There's no centralized server or that keeps all the information that can be hacked. Each radio keeps track of itself, all of its connections, and publishes that to the other radios. So it builds the tables, what they call the lookup tables, on the fly. Okay. The network. The only way you can get on the internet is by using what's called a VLAN switch. And when you have to plug, it actually takes the connection, goes straight to the radio, to the AREDN radio, strips all the tags off it, and goes and sends it to your connected device. So your connected device can go straight through the switch into the internet and back and forth. So like right now, I'm using the internet and I'm using the mesh. Okay, they're not, but they're firewalled, and I can't, like, if there's another radio or another device plugged in on the internet, it doesn't even know I'm here. It's not on the same subnet. It's not even using my Comcast server. So Comcast doesn't know that I'm on here. Okay, and you can't get to my computer from the mesh network unless I publish my computer as a link for you to get to. So it's pretty darn secure. We're not connecting to any agencies. That's one of the things they don't like us to do. They don't always tell you, oh no, you can't bring your computer in here. Well, fine. I don't want to put you're more at risk from plugging into the county network than I am, operating my own network. All right. So haven't had any trouble with that. You can, a bad actor with your password could do stuff to your radio, but that's the same as anything else. But it's not like it's really open. It's not open to the internet, to bots or anything like that that can see our system. Frank can answer any other in-depth internet stuff. Frank is that runs the state of Oregon's networks. So I think he figured out that it's pretty safe. He's the one that makes the rules up that say, hey, you can't plug anything in our system. So KJ7DZ, so I think he's still here if you had any questions about security.
Yeah, I'm still here.
So anything you want to add on the security question for how secure is our mesh network compared to other things?
Well, typically in a network environment, the things that pose a risk are usually devices that haven't been patched, that are vulnerable to exploits or what have you. Since the mesh network doesn't physically connect to the internet, and there's no way the internet can connect to the mesh, so that substantially reduces the risk of the AREDN mesh network because it's an isolated network. Now, it doesn't mean that everything that's on the mesh network is secure and patched and up to date. Chances are it's not. But the thing is the risk of the devices is basically everybody does their own and manages their own and takes care of their own. And that's the beauty of this, is that it's community supported. So that way we reduce the risk from each other.
Any other questions about, while we have Frank here, because he's the one that helped set up our PBX. A PBX is the phone system. We've even already have phone numbers for you. Frank has come up with a phone number scheme for the entire state. He and Julie over in Florence. So based on your region and your county, you already have a phone number waiting for you. Okay. PBXs are basically little phone system, private branch exchange. It's the same as an office phone system. We use old office phones, grand screen office phones, and they can link together, called trunking. So you can make a phone call from Eugene to Salem and dial a common phone number scheme. Makes sense. Frank got that all set up with us, and yeah, we can talk around the area, and it's expanded, and I think each group gets about 1,000 members. So
Yeah, so each county's basically set aside 1,000 numbers for that county to be divvied to all the different communities to connect the phones within that county.
what else can we tell you? Let's see. Someone left. Paul left.
Mesh chat.
For time, he's back to pretty late. Mesh chat?
Yeah, you want to mention that, or
Sure. Okay, yeah.
that seems to be one of the popular apps on the Mesh Network.
Yeah, okay. Let's see. So, oh, I don't have it up right now. I have to share the screen again, but I'll mention this again because people are starting to sort of fall off the map here. Mesh chat is we have some services that are kind of built in, but the Mesh chat was supported by the AREDN developers as a basic chat service, kind of like we're doing right now, except that it is mirrored to other chat servers. So when you put a Mesh chat service in, it's usually Raspberry Pi again, with one of these radios, that when I type to you and I said, hello, Bill, or whatever, it shows up on all of the different Mesh chat services, okay? I can even put a file on there and it shows up. And it does that automatically. So in that really difficult situation, how do you send a message quickly to someone in all the counties? You know, like, we really could have used this during the fire. We were ready. Nobody asked us to do it. It was a shame, but we were ready to coordinate activities on the Mesh network. You know, we could have set up the mesh and done like the wildlife thing with people being able to chat. Hey, I've got this horse here. Who's it belong to, or whatever. And yeah, you would see it in Salem. You'd see it in Clackamas. You'd see it in Polk. You'd see it in Lynn County, wherever that they have the Mesh chat set up. So it's a way of real-time communicating with other groups. And we've done that a couple of times in our set exercise to see if it works, and it does. So, and you can come back to it. So it doesn't mean that you have to have a net control operator that's like there all the time listening for someone to call for you. It's a message, it's there, so, and it's reproduced through the system. That's called Mesh chat. Other questions, comments? Yeah. Anyway, in the I don't know where all of you guys are located. I guess I just met Bill here for the first time. Bill joined the group in Lynn County to get the hospitals together. And it's really another valid use is that, with the Good Samaritan system, they've got 3 hospitals now which are connected with different devices. Okay, now they've got to do more with it. But again, we're not on the hospital system. We're not, messing up their HIPAA system or whatever, but we're there as a backup in case they need it, okay? Even if all they have to do is just, their phones are down and they want to call the other hospital, they can do that. So some of the stuff requires cooperation with businesses. Some of it is just be done on your own. You can show up in the like you said, in the parking lot at the Corvallis Hospital, you'll get on the Mesh network. So we could deploy someone there and they could help, even if they weren't ready, didn't have any staff or couldn't get in the building or something. So that's the idea of it. It's fun. Get to go out and find out where signals are. Any other, I don't want to keep you here all night, but I stay as long as I'm needed. Put Dawn to sleep. Wake up, Dawn. Hi, just kidding. Any final questions from anybody in the group? I really thank you for the opportunity to speak tonight and give you an idea of this. This is relatively inexpensive. It's fun. You get to know your neighbors and you have an immediate system that's ready to use with useful stuff on it. If you want to experiment, you want to But we also have cameras, video surveillance for this. Okay, you want to do it for yourself, you can put a camera up at your own place, see what's happening. You could, if you do an event like when we get rid of COVID and we were out helping out at parades or whatever, you know, you can put a camera up in the field and have a camera watching the event, you know, and see it all over the mesh network. Place another portable station with the race organizers. It's really just unlimited. It's up whatever you want to use it for, you know, it's available to you to use. Oh, and final thing is we're doing repeater linking. So All-Star is running on our and Fusion are planned. You can link repeaters. You guys linking repeaters, I know. Lots of repeaters, right? We can do it over the mesh. Okay. So that's another thing that some of you might want to mention to your repeater people that can be used for that.
So that's being able to pass audio and control over the AREDN system.
Both, yeah. So you can. So the Ken guy, he makes those Arcom repeater controllers. So he's using his mesh from his house to get up to his repeater and work with his All-Star node, Echolink node, to control that. And he's also working on some monitoring of the his actual repeater controller, look at things like temperature and switch channels and do whatever all the fun stuff that repeater people do. So
cool.
You don't have to use DTMF.
Yep. So guys, any more questions for Brett, or are we ready to wrap it
I
up
look
here?
all a little glazed. I'm sorry, it's so much information. But you can ask me back, or you can join more nets, things like that. Tyler's got he's sneezed on us. There you go. All right, gotcha. Hello. All right. So that's all I have for you as far as a formal, kind of demonstration. Hopefully you've seen that it's working, it's useful. It's not just a bunch of guys in a garage with a couple of low power Linksys radios with batteries trying to make them work. This is pretty sophisticated stuff. We've got links up, easily up to 30 miles. We've got counties linked. We are just looking for those special locations that are in the clear that give us the access points. The more we have, the better it works. And you can be part of it, one or more, or all.
So it's been very interesting over the past couple of years watching this grow, expand, and work its way down the valley here. And it seems like to the point you've put together the basic infrastructure to get information up and down the valley, and then now you're kind of working on filling in the cracks and filling in some of the other odd places that need additional coverage. So
For example, Florence really like to get into the valley, and one of the things that they have is a place up on what they call Herman Peak. Mm-hmm. Herman Peak's not a great location, but it turns out Herman Peak can probably see prairie. So for the Lane County people, and their emergency, they have a goal area, have money for it and things like that. If they had a place to point it, then we could connect the coast by RF as well as tunnel, which we want both RF and tunnels. But right now I'm using their tunnel. I just use their, as a resource, that those people are very good at this stuff.
Yeah, having a link from a valid or a viable link in emergency between the valley and the coast, I would think that would be extremely important. And it seems like then up and down the coast, you have pretty good linking, but you need some redundancy in that process.
Yeah, that's the idea. We want to be able to get to the, Central Oregon too. We just did a tunnel connection over there this last weekend, and hoping that people in Bend and Redmond and things will build their network up. So starting out with a tunnel, then you can plug in an RF radio, and it does take some effort to figure out where to plug it. But if you can get at least 2 people started on RF, that's the start of it, because each RF spot creates more access, right?
Yep. So we need more connections from the valley here, like to Hoodoo or Bachelor, and then use
that
those
would be
points.
A logical point to cross over if we can definitely do that. If again, up to about the maximum, it probably is practically around 36 miles, 36 to 40 miles with the devices, but you can go more power if you want. So one of our, it's what's nice is that the big dishes they use for point to point are, 34 dBi with a 600 milliwatt so input. So you can do the math. It's definitely more than 1,000 watts.
Okay. Yep, I got lots of other things I can think of, but it's probably time to wrap things up. And I
Yep.
want to thank you, Brett, for stepping in here, and all your other support guys for helping Brett out. Really appreciate that indoctrination, and it's very likely we'll have you back to take and fill in some more things as this project continues.
Yeah, very good. Well, I appreciate being here, and you got the other links that I gave you there. Make sure you copy and paste them because it disappears from the chat there of our group. And if you guys have a group or a special interest group that well, the groups.io is a pretty good group, so you can join that. You don't have to be, it's just join, and then you'll have a way of asking questions and seeing some of the resources we have there. Beginner's guide, is on there. There's a video link on that Willamette Valley Mesh page to watch the video. Okay.
Okay,
All right,
thank you.
thank you.
Appreciate that. So anything else there, Anthony?
I was just gonna say that so I get to play with a lot of the Ubiquity point-to-point stuff for work, and after the ice storm, several of my links, the link strength improved dramatically.
Cleaning the trees. Yeah, for years I've also used Ubiquity and other projects, and those are really cool devices and what they do, and it's really cool to see how they've been repurposed for ham purpose for the exclusive use of hams. Really cool on that. They are a very good, very competitive price point, and extremely efficient tools to take and use when you're needing to move data from point A to point B.
Yeah, I didn't mention the power consumption, but it's only half an amp. Okay, for one of these plugged into the wall. All right, so compare that to your regular radio. You can, run a long time on a little battery.
Yep. Well, I guess a couple of things to add for when we typically do our field day event. Bill provides us an AREDN network that we use for doing all of our communications between all of our locations within our field day premises. When we do like the 7QP, I have a couple of Ubiquity system boxes that I put up to communicate with everybody, just providing them a Wi-Fi connection. But I have a Swiss Army knife where I can use a bunch of different things along that particular line.
You're good. Yeah, and you can use our APRS system. We have an APRS server. We have a DMR server. These are things that you can build inside the system. You could build your own, logging thing or whatever. Definitely and it's nice because you don't have the internet at the field locations, right?
So your APRS server, how does that work?
Well, it is an APRS server on a regular computer that is port forwarded to the
okay,
it's
gotcha.
APRS.FI system.
Yep.
If it disconnected, it would still continue to function and handle messages from when you can use your client and just send APRS over the mesh, or you can use a radio that's connected to it.
Yep, cool.
Okay.
Anything else, you guys? Well, thank you for everything, and I'm going to get out of here.
All
I
right.
have yet to get supper, so I'm
All right. Sorry.
so I'm going to head off and grab something to eat. So thank you, guys. We'll catch you next month, same place, same bat channel, same frequency.
Okay.
Take care. Thanks everybody for coming out.